In this video, I'm going to give you a quick overview of the properties of expected value. I'm sure you know that the expected value is nothing but the mean. So these properties that I'm going to discuss with you, these are also going to be valid for sample mean. Now note that A and B are constants and over here X and Y are the random variables. So the first property is that the expected value of a constant is equal to the constant itself. Well, this is quite an intuitive property. Imagine that I have a number, so let's say 2, and I'm writing it 5 times. And if I ask you to find the mean of this, well, the mean of this is also going to be equal to 2, right? So this was quite basic. Let's move to the next property. So the property number 2 and 3 relates to the addition and subtraction of two random variables. So let's take a look at the property number 2 first. In the property number 2, we have expected value of x plus y. So let's understand the splitting mechanism over here. So this is going to be the expected value of the first term, which is x. So expected value of x. Now, because you have a plus sign over here, so we are going to put a plus sign over here. And then it is going to be the expected value of the second term, which is expected value of y. So this is the splitting mechanism that we have over here. Similarly, we can talk about the expected value of x minus y. So the expected value of x minus y, the splitting mechanism over here is going to be, we will have the expected value of the first term, that is expected value of x. Now, because over here you have a negative sign, so we are going to put a minus over here. And then we will take the expected value of the second term, which is y. So this is expected value of x minus the expected value of y, right? So this is the splitting mechanism that we have in this particular case. Now let's move to the next property. Well, the property number 4 and 5 relate to the addition and the subtraction of a constant. So let's talk about the property number 4. The property number 4 is expected value of x plus a. So over here, I'm adding a constant. Okay, now let's see how can we write this. So this is equal to, well, using the splitting mechanism that we discussed in the last two properties, this can be written as the expected value of the first term. So this is expected value of x, and we have a plus sign over here. So I'm going to put a plus over here. And then it is the expected value of the second term, which is expected value of a. Now from the first property, we know that expected value of a is equal to a. So this can be written as expected value of x plus a. So this is your property number 4. Now let's take a look at property number 5. Well, it's kind of similar. So this is going to be the expected value of the first term, which is expected value of x. After that, you have a negative sign. So we are going to put a minus over here. Then it's the expected value of the second term. So it's going to be expected value of a. And using the property number 1, it can be written as expected value of x minus a. So what do we learn from here? Well, the mean of a random variable is going to change if you add or subtract a constant. So for example, if you have expected value of x as 4, and if you add a 3 over here like this, so if you add 3 to the random variable, the mean is going to change. The mean of this will be expected value of x plus 3, which is equal to 4 plus 3 equal to 7. So if you add a constant, it will affect the mean. Similarly, if you subtract a constant, it will also affect the mean. So now it will become 1. Okay. So the mean or the expected value is affected by the subtraction or the addition of a constant, right? So this was your property number 4 and 5. Let's move to property number 6. Property number 6 relates to the multiplication and the division of a random variable by a constant. So let's see, what do we have? So this is expected value of a times x. So over here, I have written a multiplied by x, but a could be equal to anything. A could be equal to 3, in which case it will become expected value of 3 times x, or a could be equal to 1 over 3, in which case it will become expected value of 1 over 3 times x, okay, which is nothing but just the division of x by 3, but it is written in a multiplicative manner. So the property number 6 is going to be valid for the multiplication of a random variable by a constant, and similarly for the division of a random variable by a constant. Now what do we have over here? That if this is the case, then the constant will come outside. So this will become a times expected value of x. Note that there is indeed a mathematical proof of this property, but because this is just a revision video, so I'm not going to talk about the proof over here. So this is something that you can just remember for now, that if you have the expected value of a multiplied by x, then the constant is going to come out and it will become a times expected value of x. So Over here, this means that this will become 3 times expected value of x, and over here, this will become 1 over 3 times expected value of x. So now what is it that we have learned? That the mean is affected by the addition, the subtraction, and the multiplication as well as the division. Okay. Now let's move to the next property, that is the property number 7. Well, there is nothing new in the property number 7. For the property number 7, I'm just using all of these properties to show you this property. Okay. So let's see over here. So the left hand side is expected value of ax plus by. Now using the splitting mechanism that we learned in property number 2 and 3, we can write it as expected value of the first term. So this is expected value of ax. Now over here we have a plus sign, so I'm going to put plus over here. And then it's going to be expected value of the second term, which is expected value of b times y. Okay. Now using the property number 6, the a will come out. So this becomes a times expected value of x. And from here b will come out and it will become b times expected value of y. Okay. So this is your property number 7. Before I talk about the last property, note that all of these properties that we talked about over here, that is the first 7 properties, these have nothing to do whether x and y are independent or not. So for these properties, the independence of x and y, does not matter. Okay. So the first 7 properties has nothing to do whether x and y are independent or whether x and y are dependent. The first 7 properties are not going to be affected by that. However, the 8th property is actually related to the independence of x and y. So the 8th property is going to hold when x and y are going to be independent. Let's talk about this property in a bit more detailed manner. So first of all, you should know that if x and y are independent, so if x and y are independent, then this implies that the covariance, so COV means covariance, between x and y is going to be equal to 0. For those of you who do not know this, well, take a look at my video in which I am discussing the properties of covariance. I've talked about it over here. So if x and y are independent, then this implies that the covariance is going to be 0. And one of the formulas that we have for the covariance is expected value of x times y minus the expected value of x times expected value of y. Okay. Now, if your covariance is 0, that means this is equal to expected value of xy minus expected value of x times expected value of y. So if the subtraction of these two is equal to 0, then this implies that both of them should be equal to each other. So the expected value of x times y should be equal to expected value of x times expected value of y. Okay, so this is your property number 8. But note that this property is dependent on the fact that the covariance between x and y has to be equal to 0. If the covariance between x and y is not equal to 0, well, this property will not hold. Okay, I hope this is clear, and this is all about the properties of expected value.